Hello everyone. Now we're going to solve example number 16 on page 170. It says a wooden block is placed on a wooden plank. One end of the plank is slowly lifted upward. Determine the angle of the plank for which the block will be on the verge of sliding down the ramp. Also determine the acceleration of the block once it starts moving. The coefficients of static and kinetic friction, μs and μk, are 0.35 and 0.15 respectively. So we are trying to find the angle of the incline that will cause the block to be on the verge of moving. So looking for the angle on the verge of moving, those are important things. And the acceleration once it starts moving. So we are looking for two things. Already drawn the free body diagram to save some time. Weight force is downward, normal force is perpendicular upward from the surface. The friction force, since intended direction is down the incline, friction is opposing to that. And I'm using x and y that direction because if there's an acceleration, it's going to be down the incline. Okay, so what do we assume? It's one-dimensional motion, 2D forces, it's frictional surface, there's no drag force, no air resistance. We can also say the object in contact with the surface at all times. For the plan, as usual, it's a force problem. Draw free body diagram, apply second law. But on top of that, on the verge of moving case, we have maximum static, so that's the equation. This is the only time we can use the equation for the static friction, μsn, that's for the maximum. And for the second part, when we find the acceleration, we will be using kinetic friction, and that is the equation for all the time for kinetic case. And the estimation, so we expect that to be much less than 45 degrees. And for the acceleration, it's gonna be much less than gravity because it's not free fall. So for the solution, looking at the free body diagram, it's two-dimensional forces. So I'm gonna start with the x-axis. Sum of fx equals to max. And the forces along the x direction, according to my chosen x-axis, it's down the ramp. So we have wx positive and friction negative, but that friction is static maximum. And since it's on the verge of moving but it is not moving, the acceleration is 0. So the right side is 0. What is wx? Let's go back to free body diagram real quick. Let's highlight the angle. So the angle theta here is with the angle between the weight force and the y component. So right there. So the x-axis is going to take the sine function then, right? And it's going to be w times sine theta. W is mg sine theta. That's equal to fs is μs, static friction coefficient, times normal force. So the problem here is we are trying to find theta, right? But let's just check how many unknowns do we have. We do not know the mass. We have g. We don't know theta. And we don't know the normal force. So there are 3 unknowns, and I'm looking for theta. That means we need to work on the y-axis as well. So let's write the equation first. Normal force is upward, y component of the weight force downward, and again, there is no acceleration along y, so that becomes 0. That goes to 0, and n is equal to wy, which is mg cosine theta. So if you look at this, we can use the definition of n, plug it in there. Combining those two equations give us mg sine theta equals to mu s, n is mg cosine theta. It turns out, although we have two unknowns in one equation, mass is not needed, and g is also going to cancel out. Rearranging this equation, I'm going to divide both sides by cosine theta. Left side becomes tangent theta because sine over cosine is tangent, and the right side is mu s. So from here, theta is going to be inverse tangent of mu s. Mu s is 0.35. Let's go back and check that. And theta becomes 19.3. And again, it is much less than 45 degrees.